Hello world and welcome. Today we'll talk about YOLO, you only look once, and today we are going to predict objects within a picture and where they are. My name is Harris and let's get started. For more tutorials and content, hit the subscribe button or leave a like, comment there. I'll be really happy about it. What is you only look once? It's basically an image classifier that detects object locations within a picture. It's really fast. It's going by 45 frames per second to detect the object itself, and it's using a single convolution network to predict the bounding boxes and the class. Then you will have some boundaries and you will have the probabilities itself. The network understands generalized object recognition and represent the prediction of the artwork. So you will see afterwards that we are using a model here. It's an open source model which you can just download in PG Ready to just take the weights and the model itself to predict your input images, and we'll see it afterwards. So how does the YOLO model looks like? So here you have on the left the input picture of a dog who is just standing next to the bike. Above you can see there are a lot of bounding boxes and confidences. You have the class probability map here below with some colors, and then you can see the final detection within the boundary boxes, which will predict where and what you can see here basically in the image. There are also other famous algorithms, but today we'll only just focus on YOLO, who was presented in 2016. So how does it look like? First of all, we will use here the OpenCV and other libraries, as well also some function from Darknet to just take this model that you can basically download here from PG Ready. And if you have download the weights and the configuration file, you can just basically use the model here. So no need of train or test your model. Then you can print out the labels here that you can really predict whether it's a laptop, it's a bicycle, etc. And that's what you need for your prediction. Then you load the YOLO network here. Then we take just a normal picture. You can see here some street, probably in Asia, where you have some cars, you have some people walking in the streets, and then you try to predict what the algorithm will see here in this picture. That's why we are shaping the picture here. We are feed forwarding everything, and afterwards we are loop over the layers and the outputs here to detect the object itself. And then after a while we are extracting the bounding box coordinates. So it's like it's a box which is going from left to right pretty fast over the image to detect what he can see in this picture here. Then we are writing this file, the output file here, which looks like this. That you can see almost some classification here and some detection like green with green box here. It's a car, then purple here. So the algorithm realized or recognized the person here as well. So you can see a lot of boxes. But what we want to use is we want real accurate predictions. So if you have a lot of boundaries over, let's say, this blue car here, then you only want the box who has the highest probability, where the algorithm is really sure about it, that this is a car. That's why we are using the non-maximum suppression to only have one box here, where the box or this outcome is really accurate about that and really sure about it. That's why we are drawing a bounding box rectangles and labels over the image again and writing it back. Then you can see here I took the output file here where you can see, for example, here 98% probability that this is car, then we have person here found by the algorithm. So it's a pretty good example. We only have one rectangle here, which is focusing with the most probability. So the example looks pretty good here. So thanks for watching. For more content and tutorials, hit the subscribe button or leave a like, comment there. If you have some topics to cover, please let me know. You can write it in the section below, and then we can discuss these topics in the next tutorials. Thanks for watching and see you soon.